thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. My name is Mwavi Lungu, and I'm currently in Lilongwe, Malawi, and I'm very pleased to be hosting the call today. Joining me are my colleagues Apr Rai and Timothy Mtonga, along with our usual technicians from OpenO2 and Sunrai. We have Kowinda Singh, Paulina Mohosho, Mteto Sinjani, Georgie Kwanga, Francis Sambani, and Sharon Ngozo. So, without any further ado, let's dive into today's questions.
So the first question says, during preventative maintenance carried out at COVID-19 Isolation Center, I came across 3 concentrators that were connected to patients but did not have cabinet filters. No one knew where the filters were placed, and we had no spare filters in our workshop stores. Is it safe to continue using the oxygen concentrators? If not, what could be the effects of their absence to both patients and the concentrator? So I will ask Kowinda to please take this one up.
Thank you, Mavi. So, no, it is not safe to use concentrators without cabinet filters for both the patient and the concentrator. The function of the cabinet filter is to prevent large dust particles from entering into the concentrator. The small dust particles that make their way through the cabinet filters are trapped by the intake filters or the fine filters. So thereby ensuring that you have the required oxygen purity level. Hence, running the oxygen concentrator without the cabinet filter may result in fast dirtying of the intake filters. So once the intake filter is clogged with the large particles that would have been trapped by the cabinet filter, it will be having the following effects. So now you can see in the picture the cabinet filter on the back side of the machine, that is the black one. So the effects are as follows. The system pressure can be affected, which may end up affecting the purity of the oxygen to be delivered to the patient. The lifespan of the intake filter will also be shortened, thereby increasing the maintenance cost. In very dusty areas, some of the dust may find its way to the internal components like compressor and the valves. So if the intake filter is overloaded with the dust, thereby affecting the performance of these components. So if there are no spare concentrators with cabinet filters to be used in the ward, and there is an urgent need of oxygen concentrators, we will recommend you to use gauge bandage as a cabinet filter for a short period, while you look for the misplaced filters or waiting for the new filters to be purchased. So in some of the models like you are seeing on the screen, with this model, one extra filter is also coming with the new machine, so that you can search it for in the packing also. In addition, in normal cases, when you have cabinet filters on your concentrators, in order to keep the concentrators running properly and producing the required oxygen purity level, the cabinet filter should be cleaned with water on regular basis. If there is a need to keep the concentrator running while the filter is being cleaned, a spare filter, if available, can be used. It is recommended that the cabinet filter must be cleaned weekly using soapy water and should be left to dry before being put back onto the concentrator. Thank you.
Thank you very much, Kowinda, for that explanation. So if we have some questions from the audience, you are free to raise your hands, and Kowinda will help you out with it. If we also have some further comments from the other technicians, you are also free to add on to the explanation that he has just given us. So we have a poll at the end of this question. So Timothy, if you would please launch that one up.
Yeah, thank you, Maui. The poll is live now. And I'll just read the question. The poll says, do you understand the negative effects of using an oxygen concentrator without a cabinet filter before now? So I think you can just explain how to access the polls for people who may not be familiar.
Yes. So if you are joining us from your mobile phone, if you go on the bottom right of your screen, you should be able to see the menus option. If you click on the menus option, you will see an activities button there. So if you click on the activities button, the pause is one of the options listed. If you are joining us from your laptop, you also go to the bottom right of your screen, and the icon on the far right is the activities button. So if you click on that, you should also be able to see the pause menu from there.
All right, thank you, Maui. So we have received like the polls. 9 people have voted that yes, they understood the negative effects, and there's 0 for no one who did know the negative effects of using the concentrator without a cabinet filter. So this is good.
Great, thank you, Timothy. So moving on with our questions now. So the next question says, as I was troubleshooting an oxygen concentrator that was failing to start running, I discovered that the thermal switch was malfunctioning. The compressor was able to start when I tried to bypass the thermal switch. There is a ward that is in dire need of an oxygen concentrator right now, and we don't have a spare thermal switch. Can I release this concentrator to be used at the ward? So I will ask Paulina to please take this one up.
Thank you, Mwabi. So a thermal switch is an electromechanical device that opens and closes contact to control the flow of electrical current in response to temperature changes inside the oxygen concentrator. So different compressor models used in oxygen concentrators have different operating temperatures, such that when the maximum operating temperature has been exceeded, the thermal switch, which is connected to the compressor, will open, thus cutting off the current flow, and it will reclose when the temperature drops. In this way, the thermal switch prevents potential burn or failure of the compressor or the entire unit. So therefore, it is not recommended to use an oxygen concentrator with a bypass thermal switch in the wards. This is because if you consider the way the oxygen concentrators are placed in wards, you will find that they are very close to guardians, to patients, and other flammable materials. Considering this arrangement, the oxygen concentrator without a thermal switch will pose a high risk of causing fires when the concentrator experiences very high temperatures due to lack of thermal protection. The resulting thermal protection failure would be very disastrous. That is why it is not advised to use an oxygen concentrator without a thermal switch. So just bypassing a thermal switch is not a solution. You will have to find out what caused the thermal switch to develop the problem and take the proper steps to solve the identified problem. For the ward that needs this concentrator, you can borrow a concentrator from another ward while you are trying to resolve the problem of the thermal switch. Thank you, Mwabi.
Thank you very much, Paulina, for that explanation. So if we have any additional comments from the other technicians, you are free to add on to the explanations you've just given us. If we also have some questions from the audience, you're also free to ask and we will answer them. So we also have another poll at the end of this question. Timothy, if you would please launch that one out.
All right, Maui, I've launched the poll, and the question is basically, have you ever replaced a 40 thermal switch before? So we just need a minute to get some feedback, but we have 3 votes so far. All right, so it seems like the majority of people have not replaced the 40 thermal switch before. We have 7 people who have answered no and 1 who has answered yes.
Great. Thank you very much, Timothy. So in case you're just joining us, welcome you to the Concentrator Talk. And we normally start from 2 p.m. Central African time. So we discuss different aspects of oxygen concentrator use and maintenance. So if you are joining us for the first time, we encourage you to share with us your email address in the chat so that we can add you to our mailing list so that we should be sending you frequent updates from the Oxygen Alliance. Moving on with our questions now. So the next question says, I have a Vilbus 515 concentrator that has an issue with the rotary valve. Normally, I would expect the valve to rotate a certain degree and then stop, and then rotate again and stop whilst following a particular sequence. When I switch on the concentrator, the rotary valve rotates continuously without stopping. What could be the problem here and how can I resolve this issue? So I will ask Teto to take this one up.
Yeah, thanks, Maui. So oxygen concentrators require valves for feeding and purging sieve beds. So these valves help to direct air from the compressor to the sieve beds and from the sieve beds to the surrounding via the exhaust muffler. So some concentrator designs use the 4-way solenoid valve, like the ASF, to achieve the process, while the other designs like the Devil Bees 525 and the 515 newer models use the rotary valve. So the rotary valve achieves its sequence with the help of the Hall effect sensor, as you can see on the left side. So it uses the Hall effect sensor and the homing magnet. So the Hall effect sensor detects the presence of the magnet and enables the gears inside to move at the starting position of the sequences. So if the sensor is clocked or faulty, the rotary valve will continue to rotate and it will not go to the home position. This makes it not to trigger the sequences. So to solve such a problem, first, you need to check the presence of the clogging on the sensor itself. And if the sensor appears to be clogged, you can clean using benzene and a toothbrush. So after you have cleaned it, you can restore the sensor on the rotary valve assembly. And if the problem persists, the best you can do is to replace the Hall effect sensor. So another thing is that sometimes it might not be the clogging, but maybe the wire that runs from the sensor itself going to the board. So I would advise you to take a multimeter and put it in continuity mode. And then you test the wires contact by contact. If you see that one of the 3 wires is not giving out continuity, that might be the problem. So the best you can do is you could as well just solder the wire and insulate the wire as well so that you don't have any shorting. Thank you, Maui.
Thank you very much, Teto, for that explanation. I hope it was clear. So, still, if we have any questions or comments from the audience, you are free to raise your hand or paste the question in the chat and we will respond to it. Also, if you have some further comments from the other technicians, you're also free to add on. All right, so moving on, some 2 sessions ago, we got a question from Abena. Unfortunately, we have taken a bit of time to respond because there have been some other things that we suggested to her that she should try out, and we got some responses from her. So last session, we suggested for her to try out a few things, and she tried them out, but she's still having some issues. So she sent us some few extra notes on what she has done. So Francis will explain to us what those issues were and further recommendations that we managed to gather. So Francis. So we'll also just paste the question in the chat, Timothy, if you would please do that so that at least we should be on the same page.
All right, thank you, Maui. So I'll firstly just go through a recap of the solutions that we suggested to her. From the question, the problem was that the compressor was producing, or maybe let me just say the concentrator was giving out low pressure or an error, which meant to say that the concentrator has an overall low pressure. So the probable causes for this were that it said that the compressor is worn out, that is in terms of the service kits for the compressor are worn out, or either there are leakages along the pipes inside the concentrator. So the solution were that if the compressor service kits are worn out, you should try replacing the worn out service kits, and also if there are some leakages, you should replace the broken pipes or tubes. Looking at the responses that you gave us earlier, you did find leaks, and the leaks have been along those two places shown in the graphics on the right side. So we have a T connector. Just from the compressor, there's a T connector, and also a fitting that goes to the valve. So those two areas that have been pointed with the black arrows, that is, those are the areas that leak in this case. So she tried chipping off the ends of the pipes of the fittings just to make sure that they fit tight so that there are no leaks, but still more the leaks have been persistent. So now that the presence of leaks has been proved, the next stage is to correct the existing problem. It is possible that the pushing fitting itself was damaged, and that is why the problem is still existent. So to fix the leak, you have to replace the pushing fitting with one that is in a good condition, or a new one. This should solve your problem. But if you don't have a pushing fitting at your disposal, you can use some thread tape wrapped around the pipe before inserting your pipe into the pushing fitting. Thanks. So yeah, as we can see, on the graphics in the demo, we have a demonstration of how you can wrap around thread tape around the pipe and then feed it into your pushing fitting so that you don't have leaks. That can solve your problem. So just remember that when you're using the pushing fitting, you should push in the pushing collar every time you're trying to remove the pipe from the push-in fitting to prevent the damage to the push-in fitting itself. So every time you try to remove a pipe from the push-in fitting, remember to push in the push-in collar itself. That safely helps you to remove the pipe. Thank you.
Great. Thank you very much, Francis. I see we have a hand, Abena. I'm sure you have some comments, so please go ahead.
Yeah, hello. That is what I did. Okay. So this is it. So there is one concentrator that it leaks, but it's not having the E1 problem. It was able to run for 30 minutes, but it has the leak problem with this same valve.
So you are still having a leak on the T connector, the one shown in the graph?
Yes, yes, but the concentrator works.
I see. So are you able to achieve like high purities, or it's the purity is also being affected?
The purity is affected. It doesn't even bubble well. The salt water doesn't bubble well. Yes, but it's able to run for 30 minutes. Unlike the other ones that you run for 25 seconds and then it stops.
Francis, do you have any other ideas to add on to that?
So since you say you're saying that the leaks are still existent, that may be the reason why the period is down. Actually, that is the reason why the period is down. So unless you have corrected that problem, you'll be able to get a higher purity. And as in the case of the other remaining concentrators, you also be able to get rid of the error 01 that you're experiencing. So firstly, I feel like you should firstly correct the leakages themselves. So
Okay.
as we've suggested, you should either try to replace the T connector itself. If it is
Okay.
damaged, just try. Yeah, can you speak?
Yeah, I can. Let me switch off my microphone.
All right. So if you try to replace the the pushing T connector, you'll be able to, after you check for leakages and you still find out that the leakages are no longer existent, that will solve your problem. That's what we believe right now. So firstly, you should try to get rid of the leakages. So one way would be to replace the pushing T connectors. I've already said. Thank you.
Pedro, I see you also have a hand.
Yeah, so I just wanted maybe to add on that these push-in fittings, like the T connectors, like here in Malawi, they are locally available. So I believe
See, I'm not.
maybe,
I'm not getting to buy in Ghana here.
ah,
I'm not getting.
interesting.
So maybe one thing that we can suggest is for you to try and get the connector from a concentrator that is working, just to try it out on this concentrator that's still giving you issues. So if you see that it's working, then you need to find a way of trying to fix that leak, since you say you are not able to get that type of connector locally.
Yeah, with the guy who said he has a lot in Malawi, can he send me his email in the group?
Can
In
you
the
come again? I didn't get you clearly there.
there was one who said yeah, there's a lot of they have this in Malawi. So can he send me his email in the chat? I'll email him.
Okay, great. So I think we can just get in touch through the same Oxygen Alliance
Okay.
email, and then we should be able to help each other out.
Okay then. That's fine. Thank
Sure.
you.
Great. Great. All right. So moving on with our questions. Our next question says, I want to change contaminated zeolite in a DeVille-based 515, but I only have. I want to change contaminated zeolite in a DeVille-based 515 seabed, but the only zeolite available is the one a friend working at a laboratory provided called zeolite clinoptilolite powder. Can I use zeolite in the 515 seabed? So Francis, I will call you up again. Please answer this one.
Thank you, Maui. So there are several types of zeolite, the main categories being natural and synthetic. Despite having a variant of zeolite, each has a special application. The DeVille-based 515 oxygen concentrator uses synthetically made zeolite with optimized crystal structure and pore sizes for adsorption needed in the PSA system for oxygen generation. On the other hand, natural zeolites have limited applications because their properties are strictly dependent on their crystal structure. The main disadvantage is that the pore diameters are too small, like in the case of clinoptilolite, which is the most common in nature and has very small pores. This does not allow for the adsorption as needed in oxygen generation. With this in mind, the natural zeolite cannot produce anything close to the recommended oxygen purity, and because of the small pore sizes, can cause pressure buildup in the sieve beds. The synthetic zeolite used in oxygen concentrators has some of the following physical properties. They have a diameter of 0.4 to 0.8 millimeters, and they have a nitrogen absorption capacity of 23 milliliters per gram, and they have a nominal pore diameter of 10 angstroms, as well as a bulk density of 630 grams per liter. Thank you.
Thank you very much, Francis, for that explanation. So if we have any questions or comments from the audience, you are free to raise your hand and Francis will help you out. Also, if we have some further comments from the other technicians, you're also welcome to add on to what Francis has just explained to us. All right, so we also have another poll at the end of this question. So Timothy, if you would please launch that one up.
Yes, Maui, I've launched a poll, and the question is basically, have you changed contaminated zeolite before? So have you refilled any sieve beds with zeolite? Also, just to remind everyone that if you have any question of interest, you can put it in the chat and we'll do our best to answer it in this session or the next one. All right, so we have 6 votes and it's an even split. 3 have changed contaminated zeolite before and 3 haven't.
All right, thank you very much, Timothy. So now, as I mentioned at the beginning of our call, that we have a topic of interest. So today we'll be talking about humidifier bottles. So Sharon is going to take us through that. So Sharon, it's your time now.
Thank you, Mal. So today we'll be talking about humidifier bottles, how to handle them, the direction, how to clean them, how to take care of them. So as we all know, oxygen concentrators take in ambient air from the surrounding, compresses it into the sieve bed where nitrogen is sieved out and dry oxygen gas is produced and given to the patient. So supplementary oxygen can dry out mucous membrane of the patients, and this causes irritation and possible nose bleed. So humidifier bottles are important in a way that they aid in giving humid oxygen to the patients. So humidifiers allow oxygen to pass through sterile water, where oxygen picks up tiny water molecules, thereby reducing dryness and irritation to the patient. So the bottles are not just connected to concentrators only, but they are also connected to oxygen tanks or cylinders. As we can see on the graphics, we have a picture where the bottle is connected to a concentrator and the other side is connected to oxygen cylinder. So now we'll talk about the parts and function of the humidifier bottle. So the humidifier bottle has the following parts. It has the oxygen source. So the oxygen source is where oxygen from the concentrator enters into the oxygen bottle, into the humidifier bottle. We also have water level indicators. That's where we have the maximum and the minimum level. We also have the diffuser, which is also known as the filter. So the PVC filter is at the end of the inlet tube that produces very small bubbles of gas. So this part has multiple rectangular hydration ports. So this increases the contact surface between the oxygen gas and water, which helps in providing maximum humidity picked up by the bubbles. At the same time, the bubbles produce very low noise, unlike larger bubbles. We also have the humidifier safety valve, which is also known as the pressure relief valve. So the pressure relief valve pops up, or it opens or allows oxygen to pass through when pressure is built up in the bottle. So we also have the oxygen outlet port. So this is where oxygen exits and goes to the patient. So we'll talk about designs of humidifier bottles. So there are different sizes, designs, and connector configuration of humidifier bottles, as we can see on the picture. So we have the ones which have an inlet nut. On the one with the inlet nut, we have the one with the plastic inlet nut, and the other one have the metal inlet nut. So these bottles are connected directly to the concentrator's outlet. So we also have the ones with the bulb connector. So this requires a connector with bulb on the patient's outlet so that you can connect the two using a flexible tube. So the humidifier bottles can be interchangeable as long as you have the right humidifier adapters. So this adapter allows you to connect the nut end humidifier bottle to a bad end patient outlet or vice versa, as we can see on the picture. So for other models, for example, the Respironics Everflow, so we have the HEPA filter cover at the back of the concentrator. So that is the cabinet where you can find your humidifier connector tube. So now we'll talk about the directions for use of the humidifier bottle. So the first thing to do is fill the humidifier bottle with distilled water to the maximum fill level. Secondly, you need to close the bottle with the cover. So tighten carefully. You need to make sure that you thread the cap and bottle snugly. So avoid close threading as this will cause a leakage. Thirdly, you need to attach the inlet nut to the oxygen outlet on the concentrator, and you need to hand tighten. You don't really need to use any tool. So in the inlet nut, if the inlet nut is cross-threaded, it will leak. So for other models that don't have the inlet nut humidifier bottle, you need to connect the humidifier adapter to the bottle, and you need to tighten carefully. Then connect the pipe to the concentrator outlet. You need to make sure it is tight enough to avoid leaks, and make sure that the pipe you're using is of the correct diameter. Then fourthly, you need to test the humidifier bottle for the leaks. So every time you're connecting a humidifier bottle to the concentrator, before taking it to a patient, you need to test it for the leaks. So this is how you do it. So firstly, you need to set the flow meter at 4 liters. And then you need to block the humidifier outlet. So the safety valve should pop or whistle within 15 seconds. If it does not, then you need to check the bottle and lid to assure that they are tight enough. When you have cross-checked this, then you need to repeat the test until you're sure that all the connections are tight enough. Then after the humidifier bottle is attached properly, you need to connect your extension tubing to the humidifier outlet and turn the flow meter to the flow rate, to the prescribed flow rate. Now we'll talk about the misuse of humidifier bottles and their solution. So firstly, humidifier, how we misuse the humidifier bottle, we overfill the humidifier bottle with distilled water. This is when you exceed the maximum level, the maximum water level indicator. When you exceed that, it's really not good. So too much water in the bottle will cause water to collect in the oxygen tubings. So this is the tubing that goes to the patient, which is really not good. Secondly, unable to replace water at the recommended time. So this gives room for bacteria and contamination. So on the graphics, we can see the paper. So this paper is about contamination in relation to humidifier bottles. So the paper talks about water samples from reusable oxygen humidifiers were collected from 3 different departments at the University Hospital of Messina in Italy. So 100 samples were taken from each of 3 departments over a period of 6 months. And the samples of water from each bottle were cultured to see if there was any growth of bacteria. And it happened that bacterial growth occurred in 210 of the 300 samples collected, representing 70% of the samples tested. So And the similar test was done using disposable humidifier bottles, and no bacterial growth was found. So in most of our hospitals, we use the reusable oxygen humidifier bottles, and it might happen that this thing happens in our hospitals, but we are not aware of it. It happens even to our patients, but we are not aware of it. So a link of this paper will be posted in the chat for anyone who is interested in leading it through this. So you need to change water in the humidifier bottle daily. So though distilled water is used in humidifier bottles, if not changed for a long time, bacteria can accumulate and affect the patient's health. So there's also a possibility of debris forming at the bottom of the bottle. So this gets stuck at the diffuser or the filter, thereby blocking oxygen passage to the patient. Another misuse is using tap water instead of distilled water. So as we have already talked about it, tap water has impurities. So this also will give room to bacterial contamination. So we have to make sure to use distilled water. Another thing is not cleaning the humidifier bottle regularly as you're supposed to. So we need to make sure that the bottles are thoroughly cleaned every 3 days. So don't just replace old water with clean water every week. But we need to make sure that we clean the bottle and the cover thoroughly and we let it air dry. After that, we have to make sure that we store them in a plastic paper. Another thing is masking the safety valve with plaster, as we can see on the graphics. So this is really a common behavior we have seen around in hospitals. So don't close or seal the bottle lid valve with plaster. The lid valve is there for a good reason. And the lid valve is supposed to pop or open when the outlet of the bottle is closed or blocked. Every time there is pressure build up in the bottle, the lid valve has to pop. It might be either maybe your oxygen tubing is bent somewhere, and maybe air oxygen is not reaching the patient's side. Whenever there's that pressure build up, the lid valve has to pop. So every time you close that, you won't be to know. You won't be able to know that there's a pressure build up or there's a fault somewhere for you to fix it. Because sometimes it acts like an alert to you for the supervisor of the patient or anyone who is around the concentrator to be able to know that something is wrong. Another thing is securing leaks with plaster. So it's not just the leak valve, but sometimes if there is a leakage between maybe the pipe and the bottle, or maybe the cover and the bottle,
Sharon, just to stop you for a
securing that
minute.
with plaster, that is not advisable. So every time you have a leak, make sure you collect the leak. Don't use plaster to stir it up. You need to make sure that all your connection on the humidifier bottle, they are tight enough. Can I proceed?
Yeah, your mic is cracking up. I think you need to anchor it. It's making a bit of noise. Yeah, you can proceed. Sharon, are you still with us?
Okay. Another point is when connecting the bottle to the concentrator, make sure it is connected correctly. So we need to make sure that the threads of the cover and the bottle, they are aligning. Yes. Can you hear me now? Can I proceed?
Yes, you can proceed.
Okay. So we have to make sure that we use the right cover on the right bottle, the ones with the threads that are aligning. Another thing is to always check for leakages on the humidifier connection before connecting it to the patient. Now we'll talk about how to clean the humidifier bottle. So to clean the humidifier bottle, first you need to take apart the cover and the bottle. Then you need to soak the pads in warm soapy water. So this has to be done about 5 to 7 minutes. After that, then you need to rinse thoroughly in running water. When you do that, then you need to soak in a 1 part white vinegar to 3 parts water solution for 20 minutes. Then you need to rinse thoroughly and then you let it air dry. When it's dry enough, then you have to store it in a plastic bag when not in use. So you always need to have a spare replacement on hand. And every time you're done using a concentrator, you don't really need to leave the humidifier bottle there. You can take it and clean it up, then you store it ready to be used the next time you use your concentrator again. Thank you.
Thank you very much, Sharon, for that explanation. So if we have any questions or comments on the details that she has just presented to us, please, you are welcome to raise your hands or just type it in the chat and then she will respond to those questions. All right, so getting back to our questions now. Our next question says, our hospital has been using Invacare Perfecto for a year now. The performance of the machine is just okay since it is able to produce high purity of up to 90.5%. To my surprise, the concentrator is making noise whilst exhausting as if the concentrator is open. Before I go forth opening it, what could be the possible area to look on and the cause of such a noise and the solution? So I will ask Kowinda to take this one up.
Thanks, Mavi. So noisy oxygen concentrators create an unfavorable environment for the patients and the caretakers. So it is good to make your machine noise free. So the noise comes from the exhaust muffler track if it's damaged or has an opening on it. So the damage comes when the track lasts and gets weak and fails to withstand the exhausted pressure of the factory fault, leading to untimely damage. So the first thing to do is to buy a epoxy glue if available on the local market and seal off the openings. Make sure you start the oxygen concentrator after the glue settles for a perfect bonding. So, or either you can also use, if the muffler is loose, then we can use the cable ties to tighten it. If the exhaust track has lasted long, it cannot last long even after the repair, then you are advised to replace it with the new one. Thank you.
Thank you very much, Kowinda, for that explanation. If we have any comments from the audience or from the other technicians, you are free to comment on the explanation that he has just given us. So we also have a poll at the end of this question. So Timothy, if you would please launch that one up.
Yes, Maui, I have launched the poll. And the question that we're asking with this poll is, have you ever serviced or replaced an exhaust muffler track for an Invacare Perfecto? So this is specific to this particular model of concentrator.
So as we wait for the results, I would just like to remind everyone, especially those of you who haven't shared with us your contact details, to please paste them into the chat so that we can add you to our mailing list, so that we keep sending you reminders of the next concentrator talk and updates from the Oxygen Alliance.
All right, Maui. So we have received 6 votes. One person has answered yes, and the other 5 have answered no. So this doesn't, it's either the model is not common or the problem hasn't been encountered that much.
Okay, great. All right, so moving on to our next question. So the question says, I have a Lonkian J10 oxygen concentrator with dual flow meters. Each flow meter has a maximum flow rate of 10 liters per minute. What is the recommendation of using this kind of oxygen concentrator? So I will ask Mteto to please take this one up.
All right, thanks, Maury. So this question, I think it was once asked before, but it was related to the counter concentrator, the dual flow meter. So, but this one is a long phase. So while not common, some manufacturers make concentrators with 2 flow meters, and this allows the concentrators to simultaneously provide oxygen for 2 patients at the same time. So this model of concentrator is rated 10 liters per minute. So the Longfei J10 is the one on the left side. So regardless of having both flow meters in use, the total combined flow rate from both flow meters must not exceed 10 liters per minute. So for example, one flow meter can be set at 5 liters per minute, and you can have the other one set at 5 liters per minute as well. So the total gives you 10. Or you can have one set at 3 liters per minute and the other one set at 7 liters per minute. So people mistake and set both flow meters at 10 liters per minute, making a total of 20 liters per minute. And this lowers the oxygen purity to around 50 to 60%. This is true to all concentrators that have like dual flow meters. So all the counter concentrator, the Longfei, J5 dual flow meter, J10, the performance is the same. So when you're using when you're using one flow meter only, I would advise you to keep the other flow meter closed, like fully, so that you prevent the wastage of oxygen. Yeah, the wastage of oxygen. Thank you, Maury.
Thank you very much, Pedro, for that explanation. So if we happen to have some comments from the audience or the other technicians, you are open to add on to the explanation that he has just given us. All right, so moving on to our next question. So the next question says, I am a technician at Hope of All Hospital. As I was troubleshooting an oxygen concentrator that was failing to start, I found that the capacitor was burnt. What could have caused the capacitor to burn? So I will ask Paulina to take this one up.
Thank you, Mabi, for the question. The capacitor that helps in the starting and running of the compressor can get bent due to various factors. The first factor is power surges. So if the electricity supply is not stable, the compressor relies more on the capacitor for its continued running, which causes the capacitor to be overworking and get heated up, making it work outside its optimal temperature, hence its best. Voltage surges may also burn the capacitor directly when the voltage received by the capacitor is higher than the recommended one. For this reason, you have to make sure that you have a stable source of electricity. You can use a voltage stabilizer if it is necessary. Harsh environments like running an oxygen concentrator in a hot environment also promote capacitor failure for the same reason of affecting the working temperature. Therefore, you have to make sure that the concentrator is operated within its normal working temperatures. Thank you, Wabi.
Thank you very much, Paulina, for that explanation. I don't know if we have any questions from the audience or the other technicians. You are free to add on to the explanation that she has just given us. If we don't, we will now move on to our final question of the day. So the question says, under what conditions should a pressure regulator be adjusted, and why do different concentrators have different specific output pressures? So I'll ask Francis to take this one up.
Thank you, Maui. So a pressure regulator is a valve that controls the pressure of oxygen in the product tank of the concentrator to the desired value by reducing the high input pressure to a controlled lower output pressure. The pressure regulator also maintains a constant output pressure even where there are fluctuations in the inlet pressure. Different concentrators have specific output pressure depending on the model, the rated flow rate, the size of the sieve beds, as well as the compressor model. Even though the output pressures are different, it is recommended that each oxygen concentrator should be capable of generating at least 55 kilopascals or 7.977 psi at all flows up to the maximum rated flow of the concentrator. So to answer your question, you should adjust the pressure regulator only when the output pressure is lower or higher than the recommended output pressure specific for that concentrator. This mostly happens when you have changed your sieve beds to new ones. You can use any pressure gauge available to measure the output pressure at the patient outlet. On our graphics, we have images of two different pressure regulators, product regulators. The first one is mostly found in the Develbis 515 and 525, and the one on the right is mostly found in ASAP. So they have like two different mechanisms of adjusting. Depending on the regulator, you can either use a trident or flat screwdriver to adjust the pressure. For other pressure regulators, you have to pull the knob of the regulator. In the graphics, that is for the one on the right. So you have to pull the knob of the regulator and turn it either clockwise or clockwise to increase or decrease the output pressure respectively. And when you get to the desired pressure, you push the knob back in to lock the regulator. Thank you.
Thank you very much, Francis, for that explanation. So if we have any questions or comments from the audience and the other technicians, you are free to comment in. All right, it seems we do not have any further comments. So reaching this far, this now brings us to the end of our Oxygen Concentrator Talk session today. So I would like to thank you all for tuning in, and I would like to encourage you to join us again for the next Concentrator Talk session that we are going to have. Just a reminder to everyone that we encourage you to keep sending us questions, and then we are always very happy to help you out with your problems. As I pointed out in the during the session, Abena, please get in touch with us through our email address, and we will help you to acquire the components that you need. Just a reminder that we also have a website, oxygenalliance.org. So please visit the website so that you can see the different work that the Oxygen Alliance is up to. We also have a YouTube channel where we post all our previous recorded sessions of the Concentrator Talks. We also have some videos focusing on specific oxygen maintenance issues. So please have a look and don't forget to subscribe when you visit the page. So reaching this far, I don't know, Timothy, if you have anything to add on.